Okay, thank you for the introduction, Carmen. Are the slides visible?
Yes.
Okay, great. So let's go. So indeed, this presentation is about key results of this project. So two models, dynamic process model for the electric arc furnace and also scrap mix optimization related to the same process. So for the contents of this presentation, first an overview of this electric arc furnace web application, then about the key features, which are scrap characterization, scrap mix optimization, and the dynamic process model. Then about the target audience, two demos, basically videos, and how you can find more information, and then a summary. So this EAF, or electric arc furnace web application, has these two main pieces of functionality: scrap mix optimization, because it uses scrap as the input to produce new steel products. So it is important to mix the scrap correctly. More about these details in the coming slides. And the second main part is the dynamic process model, which enables the online monitoring and decision support and optimization related to this electric arc furnace process. This is also going to be explained in more detail soon. So first of all, this scrap characterization. So the electric arc furnace indeed uses scrap as the input for new steel products. And this is not trivial because the scrap varies in quality, metallic yield, chemical composition, and melting behavior, depending on the source of the scrap. So it is very important to recognize these properties basically from the practical data that we have, so we can then choose the correct scrap for each steel quality, which I'm going to tell more later. So the solution here is a statistical model based on multilinear regression, and we observe the heat data and the inputs to be able to discover the properties of each scrap type. Then the next step is scrap mix optimization. So now that we have characterized the features of each scrap category, we can then determine an optimal scrap mix for each heat, considering that steel quality we want to produce and also costs. Steel qualities are depend on the plant. Sometimes they are more, sometimes fewer, but it's important to recognize what we put into the furnace to reach the desired quality. It minimizes a cost function based on multiple factors, and of course considers also loading restrictions and scrap type availability. And quite often the situation is that the best quality scrap is the most expensive one, but still we want to use all of the scrap we have available. On the right, you can see a list of the cost factors, not going into details in this presentation, but purchase costs, meltdown, energy, oxygen requirement, carbon requirement, cost related to the environmental impact also. But you are going to see a bit more about this in the coming slides. So the EAF web application, another feature is of course then this dynamic process model. So this is for online operation. The scrap mix optimization happens offline, but this happens online to help optimize and provide decision support to the operator. It shows the melt temperature as a diagram, as well as the composition of steel and slag. And this is based on measurements. It is calculated in the background because it's not economical to completely try and measure from the furnace directly because of the high temperature, for instance. So it calculates the dynamic mass and energy balance and also thermodynamics for the metallurgical reactions. So based on equations, basically. The decision support it gives a recommendation for scrap basket charging and also when to end the burner operation in the furnace. And then it also gives an estimation how much energy should be still fed into the process, and also oxygen input when the heat is approaching its end. So what kind of target audience we have for this web application then? Steel makers, of course, with the electric arc furnace, producing new steel products from scrap. There was some, okay. Yes, let's go further. And if these steelmakers are searching for decision support to determine the optimal scrap mix, of course, monitor their electric arc furnace in real time and receive online recommendations and set points for the process control of the furnace. It can possibly be adapted to iron and steel casting, other process industries, and also maybe non-ferrous metals such as aluminum, copper, or lead, if they use secondary raw materials like scrap, for instance, and they use furnaces, high temperature furnaces for melting. And then the time for a demo. So this is now the scrap mix optimization part. In the background, we have already done scrap characterization. So now the application already knows what kind of composition the various scrap categories have. So what happens first is that the operator or whoever uses this application, maybe an engineer, has to determine a schedule they are producing. So now that we have a simplistic schedule here, we have heat number one, and they want to produce some steel quality which has been obscured here. And the next thing is to press the button optimize scrap mix. And what happens next? Now the application generated us an optimal scrap mix that consists of 6 scrap types called 1, 2, and 3, and so on this example. And it, of course, also tells us how much of each scrap type should be loaded into the furnace. And on the right, you can see calculated estimates for the environmental impact. Also that the status was optimal, so that the tool was able to find a mix that it considers optimal, and also what it costs, how much scrap is consumed in total, and so on. And there's also another key numbers. So for instance, the composition on the right, the predicted composition for the end product based on the scraps loaded, and also a scrap distribution pie diagram or pie chart. And on the right, this doesn't work very nicely when you, yes, on the other predictions for carbon consumption, electrical energy, natural gas, and oxygen. Yes, pausing, it's not easy always. It just makes my mouse disappear in the middle. Yes, and now the second demo is already running. So the electric arc furnace dynamic process model provides decision support to the operator. And for now, in this example, the process has already been running for 25 minutes, more or less, and now it tells the operator to load the third scrap basket into the process. And what happens here next is obviously the basket was charged because the calculated steel temperature as well as the meltdown degree now seem to drop. And we go further in this process. It has been accelerated by a lot because the heat would in reality last approximately 1 hour. There's further decision support. So now the burner operator, this video display is terrible. Apologies. So indeed, and the operation of the burner also starts to calculate the remaining oxygen input and remaining electrical energy to help the operator decide how to operate the furnace. And now we still go further and keeps calculating the energy input and oxygen. Terrible. Okay, and let's go. Yes, and now the next item. Now it shows in the diagram the measured temperature. You can see this blue dot. So this is an actual measurement from the process, and there's going to be yet another measurement still. And now in the background, the model corrects its calculations based on these measurements. And now the heat is basically closing to the end already, but now it shows also in this another diagram carbon oxygen levels calculated with the model, and also measurements as these dots, this brown dot and these 2 red dots measure carbon and oxygen. So various types of decision support because it is far from trivial to operate this process online. If you are interested in having more information, you can ask Bernd Kleimt or me. So you can see the addresses here. And of course, we also have a website for our research institute. You can also find more information about what we do there. As a summary of this electric arc furnace web application, so there are 2 main pieces of functionality, even more, but these are the most important ones. So scrap mix optimization to enable the optimal charge mix, determine the optimal charge mix, and also this online process modeling to provide online estimated, calculated key measures for the furnace, and also optimize the operation online. Thank you very much.
Many thanks, Petri.